So I will be explaining how to do the stacked blocks problem. So basically what's happening, there are two blocks that are stacked on top of each other are sliding amongst a frictionless horizontal surface. The surface between the two blocks is not frictionless, in fact it's rough, and it has a coefficient of static friction equivalent to 0.4. The top block has a mass of 2 kilograms and the bottom block's mass is 5.2 kilograms. So if a horizontal force is applied to the bottom block, what's the maximum value the force can have before the top block starts to slip? So the first thing you have to do in a forces problem is obviously draw a free body diagram. So this one's for mass 1. You have the mg force, and then you have, of course, the normal force, and then the Fg, or like the force of the horizontal force. No. Excuse me. This is just the force of it going this way. And then on the bottom block, you have the normal force, or you have this normal force, but the m1g is pushing down on top, and the normal force is not a gravitational force. The Fg, also known as the static friction force, is in the direction of the motion, and it's causing the top block to move with the bottom block. And then the Fn1 is the normal force of the top block pushing down on the bottom. It is not the gravitational force, like action-reaction forces. And this is Fn2, which is also action-reaction force. And then there's no friction on the surface, so the frictional force isn't on here, and of course there's m2g. So we have the sum of the actual forces of both the x and the y components of each force. So force 1x is just simply the force of the static friction, and then the force of 1y is the normal force minus m1g, and then force 2 on the x direction is just the total force minus the force static, and then force 2y is just the normal force 2 minus the Fn, the normal force 1, minus m2g. So because there's no acceleration in the y direction, the Newton's second law applies, and it's literally just Fn1 equals m1g for the first force, and then for Fn2 it's just Fn1 plus m2g. And then if you're adding them up, then you get m1 plus m2g is the total force. So F2x equals m2a, and then m2a yields from F minus F1, and then that also equals F minus mu s Fn1. And then if you do a little more algebraic manipulation, you get m2a, the total force equal m2 times acceleration plus mu s times Fn1, and then that would equal this thing. And then when you simplify it, you get ms, or the mu s g times m1 plus m2. So when you're substituting in this static friction coefficient times g, 9.81, and then you just add the forces together, you get 28.65 newtons, and that's the total force needed. So yeah.